Hi, our today's discussion is going to be about solving quadratic equations using a specific method. That method is called square root method. So first of all, let's make sure we understand. Square root property says that if you have an expression that looks like x squared equals some number, then we can always find x by taking the square root, but we need to remember it's going to be plus or minus that number. Okay? And that's pretty much how it's going to work. I do want to mention one thing. I have examples here. They're going to be 1 through 5. They're intended for students who are not above Algebra 1. And I'm going to have some examples that are going to be meant for students who are in Algebra 2 or above that. And I will mention that. Then I do have a real-life example that is good for everybody. But everybody can watch this. So this perfectly matches that. So from there we are going to say, okay, if x squared equals 16, then x equals plus or minus square root of 16. I'm going strictly by that. We know square root of 16 is 4, so x equals plus or minus 4. That means we have two values, positive 4 and negative 4. Okay? X squared equals 24. We are going to follow exactly the same process. X equals plus or minus square root of 24. Now, like the previous problem, square root of 24 is not a perfect square, so we're going to have to simplify that. If you simplify square root of 24, we're going to view 24 as 4 times 6, with 4 being the perfect square. So we're going to have x equals plus or minus 2 square root of 6. And those are going to be our answer. 2 square root of 6 and negative 2 square root of 6. If you look at example 3, you need to be careful about one thing. You do not have x squared by itself. So we are going to add 1 to leave it by itself to both sides. We're going to have x squared equals 9, right? And then it looks like the other problems. X equals plus or minus square root of 9. X equals plus or minus 3. So 3 and negative 3. Remember, when you solve quadratic equations, most of the time you are going to expect to have two solutions. And that's exactly what we're getting here. Alright, let's move on. We do have a couple more that are pretty basic. So an example like that, it doesn't say x squared, but we do have some quantity here, and the whole quantity is squared. So the way we approach these problems is going to be x plus 1 equals whatever we have here. It's going to be plus or minus square root of 121. You do not touch this 1 until you are done with this. So square root of 121 is 11. So we're going to have x plus 1 equals plus or minus 11. And these problems you are going to have to write two separate equations, because plus or minus 11 means you have positive 11 and also negative 11. So this gets broken up into x plus 1 equals 11 and also x plus 1 equals negative 11. This equation gives you 10. This equation gives you negative 12. And that's what we have as far as our answers. Alright, example 5. Very similar to what you saw in example 4, just a little bit more. So what we're going to have here is we're going to handle it the same way. Whatever we see here that's squared, we are going to apply that property. So 2x minus 3 equals plus or minus square root of 64. Right? 64 is a perfect square, so 2x minus 3 equals plus or minus 8. And just like the previous problem, we are going to have to split it into two separate equations. So 2x minus 3 equals 8. And then 2x minus 3 equals negative 8. So plus 3, 2x equals 11. Divide both sides by 2. You have x equals 11 halves. And here we're going to do plus 3, 2x equals negative 5. Divide by 2. And x equals negative 5 halves. And these are the solutions. Again, we're getting two solutions for these problems. Alright, so the next two problems are meant to be for students who are taking Algebra 2 or above. Students who are taking Algebra 1 will be unfamiliar with that, but I would stick around or scroll to the end because there is an application problem. So let's address this. If we're trying to solve this equation, well, first of all, we need to get rid of this 81 because we need to have x squared by itself. We already had one problem like that. So minus 81, that gives us x squared equals minus 81. So you're going to do x equals plus or minus square root of negative 81. Students who are taking Algebra 2 or courses above that should know this is going to give you an imaginary answer. That means x equals plus or minus 9i. And those are going to be our solutions, 9i and negative 9i. Okay, and the same concept is going to be used with example 7. So we have a quantity squared equals a number. That means 2x plus 1 equals plus or minus square root of negative 36, which is going to give us 6i. So 2x plus 1 equals plus or minus 6i. Right? And just like the other problems, we're going to have to split it into two separate equations. The first one is going to be 2x plus 1 equals 6i. The second one is going to be 2x plus 1 equals negative 6i. So here we subtract 1. You do need to be careful because 1 and 6i cannot be combined. They're not like terms. So we are actually going to keep both of them. So you got 2x equals negative 1 plus 6i, and then we divide both sides by 2. If we write this in the proper form for complex numbers, it is supposed to be written as negative 1/2 plus 3i, and here we're going to have 2x equals negative 1 minus 6i, divide by 2, x equals negative 1/2 minus 3i. Complex numbers, and these are the solutions, negative 1/2 plus 3i, negative 1/2 minus 3i. Okay, I do have one problem that is good for anybody, which is an application problem. Let's take a look at that. So we have the following situation. When all sides of a square enclosure are increased by 2 feet, the area of the new enclosure is 576 square feet. What are the dimensions of the original enclosure? Let's visualize it. So we consider this to be original enclosure. Its dimensions will be x and x, right? That's a square, all the sides are going to be equal. So we extend this by 2 feet. We extend this by 2 feet. And our new square is going to be kind of like that. So what is the length and width of each one of them? So we took x and then we added 2. So this whole thing is going to be x plus 2. And this whole thing here is going to be x plus 2. So the dimensions are x plus 2 times x plus 2. And when you find the area of a square, you multiply the side by itself, so x plus 2 squared. And we know that the new enclosure, the one that was enlarged, is going to be 576 square feet. So we're going to do x plus 2 equals plus or minus square root of 576. X plus 2 equals plus or minus 24. Alright, so yes, a quadratic equation is going to have two solutions as general rule. However, this is a problem that has a real-life context, and a negative number here will not make any sense. But let me continue with this. So we have x plus 2 equals 24, and we have x plus 2 equals negative 24. So the first equation here is going to give us x equals 22. The other one's going to give us x equals negative 26. We are going to reject that answer because we cannot have a negative dimension. Okay? Only a positive number is going to make sense here, which means 22 feet, right? So the original dimensions were 22 feet by 22 feet. Okay, and this is how it's done. Hope this helps. We'll see you next time.